Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 1 from chapter 9, which is looking at linear equalities in two variables. So an inequality with two variables describes a region in the Cartesian plane. And the solution region is all the points in the Cartesian plane that satisfy an inequality, which means that it works or it holds true if you were to verify it. And you can also call it a solution set. So there's some steps for when you're graphing a linear inequality. So your first step here is you have to solve for y if it's not already done so. And then you're going to graph the inequality as if it were just a normal straight line in the form y is equal to mx plus b. This line that you draw is called the boundary line. And one way we can show a distinction between the different inequality symbols is by drawing a solid or dashed line. So if the inequality is greater than or equal to, or less than or equal to, the boundary line will have a solid line. So it's going to look exactly like we would have graphed in our earlier chapters. So this means that we include those values. So that means points on that line will also be a solution to that inequality. So if it is only greater than or less than, so not equal to, then it's a dashed line, meaning you do not include the values on in that solution set, or I guess within the number of solutions. Then what you need to do is, then you need to shade the actual solution region. So to determine this, what you do is you choose a test point. So you pick a point on either side of the line and then you substitute it into your inequality. If the inequality is true, then that region where that point is the solution region. And one thing that's really important here is it has to be on either of the sides. It cannot be on the line itself. So your test point cannot be on your on your line. Sorry, I guess on your boundary. So first we're going to look at some examples here. So here we have the example y is greater than or equal to negative 3x plus 4. So what you would do is you would graph just y is equal to negative 3x plus 4. And then that inequality symbol here just determines whether or not it's a solid line or a dashed line. So this case here we have greater than or equal to. So it has that equal to sign, meaning we can include the points on this line, so it's a solid line. Then what you would do is you choose a test point on either side. Typically you want to go with the easiest one. As long as 0, 0 isn't on your graph, then you can test it. Or if it isn't on your line, then you can go ahead and test it. That's the easiest one because then you're working with just 0 is greater than or equal to. So it'd be negative 3 times 0, which is 0 plus 4. And then we say 0 is greater than or equal to 4. We know that isn't true, so then we have to shade the other side. All right, so then looking at y is greater than negative x minus 5. So here we do not have an equal to sign here, which means that we have a dashed line. So you would graph it as y is equal to negative x minus 5. And then that inequality symbol means it's a dashed line. Then once again, you choose your solution point. So this point here, we see that it's shaded. So if I were to choose 0, 0, we would see that this works. It's in our solution region, which means that it should be a point that works or holds true in that inequality. So we'd have 0 is greater than, so we'd negative 0, or just 0 minus 5. And then 0 is greater than negative 5, which is true. Awesome. So that means that we would shade this side of our graph. If not, we would shade the opposite side. So now we're going to look at an example from your notes, which is example number 2a. So here we're going to graph inequality, and here inequality is y is greater than 3 over 4x plus 2. So my first step here when we're graphing is you first want to write whether or not you're going to have a solid or dashed line. You want to write that right from the get-go, that way you don't forget about it. So this one here, your inequality does not have an equal to sign, which means that it's going to be a dashed line when we're drawing this. So that's your first step. So identify whether or not it's going to be a solid or dashed line. You can even write this nice and big so you've got lots of room so you remember that it has to be a dashed line. Then what you're going to do is you're going to write this inequality as an equation. So you're going to write y is equal to 3 over 4x plus 2. So you're literally going to replace this inequality with an equal sign. And that's just to help you out when trying to solve and find values for your graph. So we're going to do a table of values. And when I'm picking points here, one thing I might note is that in our equation, we have a fraction with a denominator of 4. So if I don't want to be working with fractions, I might want to go with multiples of 4. That way I don't have to work with fractions when I'm trying to graph, because we all know how gross that can be. So I'm going to go with multiples of 4. So I might go with, say, -4, 0, and +4. So remember, with a straight line, so with a linear equation, we always want to choose at least 3 points, because 2 will create that straight line, and then the third one will make sure that we did our work right. So if they all line up and create a perfect straight line, we've got a pretty good idea that we've done our work right. So then what we're going to do is we're going to plug in each of these x values into our equation and solve for y. So we'd have 3 over 4 times x, which is -4, plus 2. So 4 divided by 4 would give you 1. So we're left with -1 times 3 is -3, then plus 2. -3 plus 2 is -1. Then we have x is equal to 0 here, so we're going to go 3 over 4 times 0 plus 2. Anything multiplied with 0 will just give you 0. So you have 3 over 4 times 0, which will give you 0, plus 2. That should give you +2. Then our last one there is when x is equal to +4. So we have 3 over 4 times 4 plus 2. So 4 divided by 4 cancels out, so you're left with 3 times 1, which is just 3. Then 3 plus 2 is 5. So because this is a linear equation, we know that it should be going up by the same number. So to get from -1 to 2, you're adding 3. Then to get to 2 to 5, you're adding 3 here as well. So you're going up by the same number, which is exactly what our rules or properties are for a linear equation. So then we can go ahead and start to label our axis for our graph. So our first one here is we want to label our x-axis, and we need to make sure we fit 4 and -4 on our graph. So looking here, we have 10 lines going from the origin out to the edge. So we could really go every 2 lines to be 1 value. Then we can do our y-axis as well. So here we need to fit -1 all the way up to +5. And so we can really do the same spacing here. One thing I will caution you is that you want to make sure you try and use a little bit, well, I guess a fairly good chunk of your graph. So you want to make sure your graph isn't going to be in like a corner over here, because then you won't really be able to tell whether or not it's an inequality and where you're shading. So if all of your values are really close to this outside, so say if they're really close to, say, maybe there are 3, 4, and 5, so to create a really small line here, you might want to change your spacing. That way you can get your line a little bit more in the middle, so you can see whether or not you're shading on the left or right side, and help us understand that inequality a little bit better. This one here, we have a pretty good spread. We go from -1 to 5, then -4 to 4, so it's going to cover a good chunk of our graph. So now that we labeled our spacing, now we can go ahead and start graphing. And just remember that when we do our line, it needs to be a dashed line. We plot the points as we always do, but then when we're trying to connect those dots, it's going to be using a dashed line. So here we have x equal to -4, y is equal to -1, x equal to 0, y is equal to +2, and then 4 and 5. So then because we know what this is linear, this should be a straight line. So you should use your ruler, but make sure you have a dashed line. So as you're going through your ruler, you're going to create, you'll just lift your pencil up and down. And make sure you put arrows on each end. So mine's just a little bit of a ballpark. You can see I have quite a shaky hand here. But as I said, use your ruler and then just lift up and push down every now and again to get a nice dashed line. So then the last part here is that we need to make sure we do our shading, because it's not just a straight line. We have what's called that solution region. So to do your test point, you're just going to choose a random point that is not on this line. And whenever possible, you should always go with 0, 0, because it's got the easiest calculations. So in this case here, 0, 0 is not on this line, so let's go ahead and choose that. So every time you see x, you're going to put in 0. Every time you see y, you're going to put in 0. So you have 0, and you want to put this into your inequality. So 0 is greater than 3/4 times 0 plus 2. So 0 is greater than 3/4 times 0 is just 0, so you have 0 plus 2, and 0 is greater than 2. So then you ask yourself, does that make sense? Is 0 greater than 2? And that is a no. 0 is not greater than 2, which means that 0, 0 is not a solution. So that means that if 0, 0 was on the right side here, or if you want to call this the right diagonal, that means we have to shade the opposite side. So then take your pencil and just neatly shade the opposite side then. And I'm going to use my highlighter tool here. So it shouldn't be colored in like super hard with your pencil. You want a nice light shading so you can still see this graph and your spacing behind here. And then once you've done that, make sure you guys do your shading here. Then you guys are done. So when we're talking about this shaded area, this here is talking about, I guess anything in this area is a solution. So if I put in -5 and 0, this would hold true in our inequality. 0 and 3 would work. 0 and 5. So anything in this shaded area will be a solution to this inequality that we have above in that question. So there is everything here for this video. So thank you guys so much for watching. If you guys have any questions, make sure to come see me in class or text me on Remind 101.